Alright, I know this is a little challenging, but wanted to give a little bit of help here on the homework, particularly finding the equations of these lines. One thing to keep in mind on all of these is that when you're finding these, you need to really try to identify a couple things first. First of all, identify the amplitude, identify the period, and identify if there is any translation. So those are the three main things we're looking at. We're looking for a function a times the sine of bx minus c. Any of these could be written as cosine functions, but they're telling us specifically to use sine. So, remembering what we've looked at before, we can see the sine curve right here in gray. Sine always starts at 0. The period's going to end at 0. There's going to be 0 in the middle. It's going to go up first, then down. Alright, so as we look at these different graphs, one of the things that you need to do is simply pick a starting point. And really, it's kind of up to you where you want that starting point to be. Alright, in this case, I could put a starting point here. Alright, and this one over here, you'll notice it's starting going up and then down, so the starting point could be right here at the origin, which that's nice. On number 67 over here, we could have the starting point right here. And then on number 68 here, we could make the starting point be this right here. Now, obviously this isn't the only way that you could do it. We could have made the starting point here, or we could have put the starting point over here. Or, for example, on 65, if we wanted to put the starting point at the middle and then see it as something that was reflected across the x-axis, we could do that. But for the sake of these examples, I'm going to do it this way. Okay. Next, let's identify the amplitude. And we'll do that for each of these. The amplitude, remember, is how far up or down our function goes from this midline. You'll notice there's 1, 2, 3 marks up and 1, 2, 3 marks down. So our amplitude equals 3. Okay. On number 66, it goes up 2 and down 2. So our amplitude equals 2. Alright, and notice I'm putting a equals 2 because the way I put the starting point, none of these are going to be reflected, at least not the way that we write it. So your amplitude would equal a. That wouldn't necessarily be the case if you were going to reflect it. A would be negative, but the way we're doing it, that's how it's going to work. Okay? Here, we're just going up 1 and down 1 for number 67, so a equals 1. And then for number 68, again, we're going up 2 and down 2, so a equals 2. Okay. The next thing we need to do is identify the period. So we need to figure out the ending point and then figure out what the distance is there. So if we come back here, one full period is going to go up and then down and then back up here to 0. Alright, so to figure out the distance here from 0 to the end here is 2 pi. So halfway is going to be pi, which means this function starts at pi over 2 and then goes to 3 pi over 2. Okay, so from pi over 2 to 3 pi over 2 is a distance of pi. Okay, so we have pi there for the period. And I'll just type that since that isn't turning out real well. Okay, so your period equals pi. Here, you'll notice, but we don't get back to 0 until all the way over here. So the period goes from 0 to 4 pi. So our period equals 4 pi. Okay. On 67, from our starting point, it actually goes off the screen a little bit. So we could do this one of two ways. We could either just find the half and then double it, or we could actually go backwards a full period. And it's really up to you. I'll just look at what this distance from here to here would be, and I know the other half is going to be equal to it. All right, so if this is 2 pi, and we're marking this, this right here would be pi. This would be pi over 2, and this right here would be pi over 4, our starting point. Okay. Now this would be 3 pi over 2, and this right here, halfway between pi and 3 pi over 2, is going to be 3 pi over 4. Alright, so we have a distance from 3 pi over 4 to pi over 4, that if we subtract, that's 2 pi over 4 or pi over 2. Okay, and we're going to take pi over 2 then and multiply that by 2. Okay, so pi over 2 times 2 to get the whole period is just going to be pi. Alright, so that's our period for number 67. Okay. On 68 here, again, you figure out, here's negative pi over 2, here's a negative pi over 4. We're approximating because we don't have an exact scale, but that's alright. So that's negative pi over 4 up to pi. Okay, so that means our period is going to equal 5 pi over 4. Pi over 4 plus pi for a full period gives us 5 pi over 4. Alright, now each of those can help us find B, because P is always going to equal 2 pi over B. Alright, so if I figure that out here, if pi equals 2 pi over B, then B must equal 2. Okay, so, alright, we'll put that here. B equals 2. Alright, there's B equals 2. For this one, if 4 pi equals 2 pi divided by B, we must have divided by 1/2. Then you flip and multiply to get 4 pi. Okay, here pi equals 2 pi over B, just like in 65. So once again, our B equals 2. And then down here, this might be the more challenging one to find, but 5 pi over 4 equals 2 pi over B. If we multiply that out, we're going to get 8/5. The pi's will cancel, and B will equal 8/5. Alright, once you have those, then it's a matter of identifying the translation. And what we learned was that the horizontal shift will equal C over B. Alright, so in order to figure out what C is, we need to do the horizontal shift times B. Okay, so here we have a horizontal shift on number 68 of negative pi over 4. So negative pi over 4 times 8/5. That's going to give us a negative 2 pi over 5. All right, so C equals negative 2 pi over 5. All right. On this one, we're shifting it to the right pi over 4, so that's a positive pi over 4. So C equals pi over 4 times 2. So that's going to give us pi over 2. So 2 over 4 reduces to 1/2, so it's 1/2 pi. For 65 up here, it's shifted to the right pi over 2. Okay, so pi over 2 times 2 is going to be pi. So C equals pi. And then on number 66, this one wasn't shifted at all. So in this case, C equals 0. Okay. Once you have all this information, then it's just a matter of plugging in your A, your B, and your C into your equation. Be careful with 68 because you'll have minus a negative 2 pi over 5 when you do the minus C. So that'll be a plus 2 pi over 5. Alright, for example here, we're going to end up with f of x equals a times the sine of bx. So I'll do 8x over 5 minus a negative, so that's going to be plus 2 pi over 5. And obviously I have pi written out, but that's going to be your equation. Alright, so hopefully this is helpful. Get you going on these. The remainder of the homework, you're using a graphing calculator here. Use the graph to determine the months of max and min sales, okay? Because you're looking at monthly sales for 1 year, set your windows so that your X, which would be T here, would go from 0 to 12. Now 1 corresponds to January, so you could make it 1 to 12 if you want. But you'll look for that highest point, lowest point. Here as well, remember when we talked about modeling, to find the trig model, you can see here your 0 is going to be the min, because obviously you can't have less than 0%. And then 100% of the moon, that would be like a full moon. The 0% would be like a new moon. And then you've got your half moon here. And you can tell what your period is by looking at the number of days. You can obviously see your amplitude is still going to be 1. Or I'm sorry, your amplitude is actually going to be a half. But you should be able to find the trig model for that. You'll have to do a little bit of horizontal shift on that as well, like we did on the other ones. Then there's just a couple of questions that you might already know the information for, like on D, by the time you've gotten the trig model. So hopefully this is helpful. Here you're kind of doing the like what you were doing on the first couple problems. Here you do not need to sketch, just use this as practice to identify, hey, 1/2 in front of the tangent is going to cut the height of it in half. A negative is going to reflect number 7 across the x-axis. The 2 is going to double the height. The 2 and the 2x is going to cut your period in half. So instead of tangent having the period of pi, in this case it's going to have a period of pi over 2. So identifying some of those things just for some extra practice will be good. Alright, again, hopefully this is helpful. Hope you guys do well.